How's it going, everybody? That was good timing with the music. A little bit of a low-key stream today, and I don't think we're gonna go super long. It's been a week, past week, and client has prod release stuff coming up and work things, and it's fine. So we'll do a little bit of a quicker stream here and look at one of the examples, maybe a couple more. We'll see how long it goes, or how long it takes to look at this first example. But what we want to look at today is when you're working with the web. So just think like a web app. When you're working with a web app, you might make a request to pull down a file from a URL. When you're in the context of a Tauri app, you don't have to have that paradigm. You could package those type of assets within the binary. So you could have a video file literally embedded in that app. Trade-offs. But even if you're not embedding that, you have the ability to use Rust to be able to handle the request or handle loading the file and then stream that to the front end. I think in V1, this was a little bit more performance sensitive, maybe I would say. The IPC changes in V2, I think, have improved this, which is partly why this example now exists. But I thought it would be interesting to check it out and kind of look at the main Tauri repo and see how that's set up to where you can run any of these examples. So if you're following along, you could pull down the Tauri repo and run this yourself. It's literally using the version of Tauri within that workspace. So it's a big Rust workspace. So let's go ahead and switch over. I like the good to see you stop by, Nicola. Which is the face blue eyes. I like the emoji. This is still what we were looking at last week. Whoa. Okay, GitHub, Tauri apps. So we're literally gonna go to the main Tauri repo. Why is GitHub having troubles? CSS is not loading from here. And we're gonna clone the repo. I think I have it already, so I'm gonna fetch. Oh, I don't actually have it yet. Okay. I think I've got things set up to work over HTTPS. So we're gonna do a little bit of this. It does. I'm blind. I don't know. I literally looked right at it and didn't even see it. Okay. Git checkout. We are using dev. Actually, I can do I've got my aliases set up on this computer. I always forget about that. Fetch. It's gonna be a big fetch. And pull. GCM. I could have done that too. Let it reset. What is there that a reset isn't working? On stage, discard. Weird. I don't know why a reset wasn't working. I have a couple of aliases set up. GCM checks out the main branch, so git checkout main. So whatever like the default branch is, it does a checkout. You can go to. I've got I'm pretty certain I've got it up to date. I have been known to forget to update, especially files that we do on stream, and then I get off stream and then I immediately forget to follow up with it. But we should have new shell. So there's a new shell config that do I guess I don't have it. Template. Oh, and maybe it's in the template. Here we go. Okay. GCM. It is using the GitHub CLI, and it figures out, it does basically a fetch to figure out what the main branch is, and then checks that out. And they might actually had that command embedded now where I could just use that directly, but when I first set this up, there wasn't like a GitHub CLI command to do that. And I got a couple other niceties in here, but here I've got a GFP does a fetch and then a pull. All right. So if we look at the, did I open? Yeah, I opened VS Code already. If we look at VS Code, the repo in VS Code, we have a couple folders in here. Tooling and core is going to be where most of the like main code lives. Tooling ends up being more of the JavaScript package type things. For the most part, the bulk of the, I guess you could say the bulk of the code is written in Rust, and the JavaScript at this point is mostly like wrappers around that to then invoke those Rust commands. So like the CLI, you can see that's JavaScript. Here, node. And it ends up being mostly a wrapper. So this CLI is Rust. Bunch of Rust in here, and then this node CLI/node is mostly just a wrapper around it at this point. And bench, I would kind of like to come back to that, because I think these are going to be more interesting to test now that V1 and V2 was a lot about feature development. V3, V4, I think it's going to end up being more interesting to really push on the performance of things. But core is going to be the bulk of your actual like Rust code. And this is a typical is paradigm the right word? A typical pattern that you would see in Rust, where and specifically because Cargo is kind of set up to handle this, you'll have a examples folder at the root, and that example folder is set up. If we look at the main README here, I guess it mostly just points to the other folders. But if we look at, where is it? Streaming. In the README here, it is set up to like run these examples. So from the root, we can literally just do this command. It's going to run that. And what's nice is this example is set up to where if we look at the index, there really isn't much in here. There is a reference to the main core somewhere that I am not seeing. So it's set up as it is set up as a workspace. So we've got a workspace with members, and then each of these core packages will, rather than defining its own values for package metadata or for dependencies, the dependencies you can see here are much more a little bit more involved than like your Tauri app might end up being, but like it's either path or workspace references. And here we've got a bunch of okay, so this is how the examples are mostly wired up. The main Tauri like core code as these examples that are defined. So these examples that we were just looking at, so here's the streaming one. It's defined there. So then that allows you to run the cargo, make that just a little bit bigger, cargo run example streaming. And what it's going to do is it's going to compile the core code, anything in the tooling that it needs to, and the example to be able to run all of it. So it makes it really easy, especially when you have a handful of these examples. Like this API example is a really good one. Unlike the multi-web view and multi-window, there's a lot that goes on in that kind of stuff. And I mean, we've got tests, but being able to also just like run an app very easily that implements the thing that you care about, that's very helpful. I feel like my music is really loud. Maybe it's just my ears. It seems like it's not too bad. Let me know if it's a little bit too loud in the stream. So here's the streaming. Now what's happening is it's actually streaming a video. And I think it's actually, this sound is actually coming through too. Let's mute the music for a sec. No, it's not. Okay, cool. So what's happening is it's downloading a file on the fly in Rust and streaming it to the front end. So let's go ahead and and there's really not much else in this. This is effectively just a script tag, I think. If we look at the inspect, I mean, it's a video source, then a script tag. So there's not too much going on in the JavaScript side of things. We're using the invoke and basically grabbing that file and streaming it. So most of the heavy lifting, happens within Rust. So I think this is going to have specific use cases. I think like doing video is probably going to be one of the bigger use cases for this type of setup. So we've got this is just like a sample video that you can that's hosted on Google, and what we're doing is we are defining a video file path buff in that URL, and here we can see it's downloading it on the fly. So and here you can see what it's effectively doing is it's using curl in the background to download this file. And we've got some I'm looking at the config attributes. We have HTTP range standard. Okay, so what it's this, I'm pretty certain is still executing like on the client. So rather than using a dependency, I mean they got a mention here. Rather than using like a Rust HTTP client, something like request. It's spelled with a W. It's using curl and just like executing it in the background. So when you start up this program, I'm presuming for the first time, yeah, if video file doesn't exist, it's going to start it up in the it's going to download it in the background. So rather than bundling this in the actual binary, it's downloading it in the background. You can certainly include it in the binary though. And I think we'll look at this next bit in a moment. We've got a invoke handler. Tauri video UI. Okay, so that sets up the command, and then we get this. I think is the bit that is doing the like streaming part of it. Hey, good to see you. I'm doing pretty well. We're not doing a super long stream today though, so it's been a week. But like part of last week, and since last stream it's been a week. But you know, we're getting along. So this get stream response is an API within, if we can get this hover to work nicely here. We get a request and a response, and this register asynchronous URI scheme protocol comes, I guess it's just directly in the builder. I think it is part of Rye. And here's the two bits. So part of looking at this is I haven't really seen or used this in other places, but also these config attributes. We haven't dug in too much to those. So I think checking that out is something that's gonna be nice. We'll come back to this command in a minute. I'm gonna shrink it down here. So the register asynchronous URI scheme protocol. This we are setting up a URI scheme of stream, and then we're executing this function. So this sets up a path, and if it return arrow 44 if it's not our video. So basically it's checking to confirm that the only thing you're running is this test video done before. You're not familiar with today's subject, and I'm vaguely familiar with it, but that's partly why I wanted to go through it. It was I think knowing that this exists is helpful as just a subject matter, but I don't know how much I don't know how much you'd see it in a typical app. In a typical Tauri app, at least. But knowing it exists and it is an option is interesting. So it sets up a path, and if the path isn't the actual like test video, then it we 404. So it's basically enforcing that we are downloading this file and that it happens to be named test video. Getting the file length. So the file length is valuable when you're streaming because you want to stream the whole file. So rather than sending a file and waiting for the file completion to end, you're like delivering it over the wire in chunks. Interesting. Linux will always return empty headers. Okay. So it's setting up this HTTP response. Content range. And like this is something that's sort of like a web feature. So you can, like, there's streaming APIs built into the browsers where you can, rather than, you know, like you go to YouTube. I'm pretty certain it uses something in this vein. Video is definitely one of the places that I haven't dug into as much on the web, but I'm pretty certain these APIs are very, very much browser based. So this, I mean, yes, but not because of this. So video chat or video between multiple people, that generally is done over WebRTC, which is a different protocol. So it's doing similar-ish things where it's streaming, but it's just like a long-running request, maybe more in the vein of like a WebSocket, where you open up the connection. WebRTC has the ability to do peer-to-peer, so you can theoretically, assuming all that networking is in place, open up a connection from me video chatting with you and deliver the video back and forth between the two clients. If you're talking something like Zoom or Google Meet or what have you, I think those are all still using WebRTC, but they also have a server in the background and they pass video through there because the peer-to-peer connection isn't always reliable. So if you are sending video between 4 or 5 different clients, rather than making the connection to 5 clients and having one client have connection issues and then it messes everybody's video up, if you're running it all through a server, you lose out on the peer-to-peer, but you gain more stability back from that. So long story short, this is a different thing. And to this comment too, you go to Netflix and I'm when you click play on like a YouTube video or a Netflix video, there's a little playback bar on the bottom. You can see that buffering filling up. So they're doing streaming and they're streaming it over chunks. And they're using, in the same vein of these type of APIs on the browser side. But the difference here is that we're handling this request through Rust, and then the response for streaming that to our front end. So a little bit different of a setup. Prince, thanks for stopping by. That's definitely on my to-do list. Crab Nebula, which is a company that funds and is highly involved in Tauri. So they fund the work, or they fund the time for multiple engineers to work on Tauri. So good chunk of the the big bulk of the time that is put into Tauri, a lot of those commits come from time that's effectively funded through Crab Nebula. I'm not involved with, but I've just been with the project for a long while, so I know a lot of the team that works at Crab Nebula. Long story short, they have put out a cloud product that allows you to host the app files. So in the same vein of something like I would deploy a web app to Netlify. You need to put your app, your Tauri app, somewhere. You could theoretically host it on something like GitHub releases, but that has limits. So that might be fine for like a little dev app. It might fit within those limits of people downloading it, but that doesn't necessarily scale. And you still kind of need some small server to do the routing. So when my app requests an update, you still kind of need to have something that handles that routing to the GitHub release page. The Crab Nebula product handles a lot of that for you. So long story short, yes, I want to make a video on that. I would like to make a video with the Crab Nebula product, and I'm sort of in talks with them to see if it makes sense to do that as a guest stream, which is why I haven't gotten around to it yet. But we'll do it. It's definitely on the to-do list. And speaking of, now that we're like way digress, check on the main page. I'm trying to schedule my streams out further than like 12 hours ahead of time. So Tauri app next week. We're gonna do it. I've been looking forward to doing it, and I just wanted to make sure that it was in a week where I would have the time where I could we could really dive into it. So once I figure out the timing for these couple of guest streams that I'm figuring out, one of those will end up being either a guest stream or not. Will be about app updating, because that's definitely a it's an involved subject, and it's not necessarily all Tauri. Like a bunch of that setup is yes Tauri and updater. There's like a couple config places, and you opt in. That's about it you need to do in Tauri, unless you want something like really custom. And then the rest is all like server. Where do you put the files? That type of stuff. So, where do you put the files received then? So this is gonna. I think you have options. In this case, what they're doing is they're specifically not wanting to include a Rust HTTP client dependency, and I think is sort of just for this example. Probably would make sense to do that. And what they're doing is they're just downloading it on the fly, and I think they're like storing it next to the file. So if you install this and it's in like the application folder and program files or whatever, it is literally calling curl and putting the video file right next to your app. What's nice about this is it's not part of the binary. So if you do an update, you don't have to download the video again. But also you have this separate file that's floating around. So you can, there is, we can check the, pretty sure there's a guide for it already. Process, upload, updater. What would it be under? Configuration? Build app. There is... If you want to include the file directly in the binary, this is, if they're like predefined and you know what they are, this is probably going to be the way to do it. So if you're just including like a video file, that's always going to be standard, and this, this might be a bit excessive, but if you wanted to put a video file as the background of your app, I mean, that's something you could theoretically do. It's going to make your app bigger. but you can bundle it directly in there because it's going to be something predefined and you're always going to be including it. It's not going to change really. You can include it directly in the bundle, and then it's when you reference it, you're referencing it very similarly. So this is using the standard file open. We're handling all of that through Rust. We could also do, so if you wanted to load a file and set it as your background in the web view, there's a file system API. And based on the, like there's some standard base directory. So rather than, so like security wise, generally you're not doing absolute paths, or, you know, like walking the file tree outside of the folder, for security reasons, because you don't want an app to be able to just have like root access to your computer. So if you're like bundling it directly in there, there's, I think there's a base directory that's basically like in your bundle. I don't see a list of that there. Here though. Probably have to pull that in and maybe look at the, I guess we could go here. Box base. Let's search for base directory. API path. References. If we go to the JavaScript API path base directory. So by default, it's set up to make it easy to refer to these default base directories. So app data, app local data, app log. These would all be places where you could grab the file and put them, or do a file picker and you click a button and you can open up a file and set these with permissions to where you can access these directories. You know, so like picture folder, that's probably something, or video, that would be something that you'd use for like Windows. And then like there's temp directories too, so you can download something to a temp directory and play it, and then basically the temp directory ends up effectively working like a cache. I think the runtime is the one that's stored directly, or no, resource I think is the one that's stored directly in the binary. And then you would use, so runtime dir. Yeah. So this is the directory where it's running from, and resource, I think, is the piece that's embedded directly in the binary. Pretty certain that's it. So those would be the places where you could put it. Effectively, you're getting the file to the user in some way. Either you're doing it after they've downloaded the binary, or embedding it directly in the binary. If you're doing it after they've downloaded the binary and installed it, you can kind of put it theoretically wherever. Security wise though, you're probably going to want to use one of those base directories, because those are going to be more like user accessible and not system type stuff that you're going to run into heaps of permission considerations. So once you go through the effort of getting the file, Rust in this example is setting up a response to where, so we have a range, and that range is basically these different chunks of the file. And then we're doing a bunch of like buffer. Basically, we're setting up a buffer. And if you go to, like Netflix and you click play and you see the little like gray bar expanding, and it expands in chunks. So it's not, I mean, it's depending on how long the video is, it might look like it's just slowly expanding, but it's downloading in chunks. So what this is doing is it's calculating like what makes sense to be a chunk and how many chunks do we need to then deliver to the client. And we set this as part of the headers. And we also have this ranges.length is 1. Okay, so we, I think, are also limited by I think there's a size limit on the range or the size of a response. So I think that's this right here. So if it's 1, we can just send it in one big chunk, or one response, a bunch of chunks. And this is doing more like paging type stuff. Yeah, multi-part. So like it would be streamed over multiple responses, I believe, is what's happening. So we're essentially taking like this content. We have determined the length of the file, and we've got the file as a vec8. And we do a bunch of buffer math effectively to figure out like how does it make sense to deliver this to the client. Eventually we then return the response. So response.body buffer. So if the ranges .length is 1, then we do the buffer body here. And then if not, then we do it here. And basically it's just different switches to determine like what's the best way to deliver this file. So depending on the size of the file and how we can chunk it. So this whole get stream response then ends up being the stream response returns a result, and we handle the OK or the positive case, and then the error case, the negative case. So if it's all good, just respond with HTTP response. Otherwise, we are responding with a bad request header or status. And as you might see in some, just doing web app type work, errors tend to be in like plain text, unless you're talking GraphQL, then no, but that's a whole different issue. Just making sure I don't have any messages that I need to deal with. Okay. So the other bit we wanted to look at was this command. So we've got this invoke handler, and what it is setting up is it's doing the generate handler and setting up a Tauri command. We'll get to the content here in a second. Let's look at the indexed HTML. There's no separate JavaScript in this example. It's using a script tag. So we are doing, we've got the configuration is set up to pull in the global version of Tauri. We then don't need to define our own builder for when we're doing local dev or for compiling the assets. And we can use Tauri directly on the main window object within the web view. It's got an invoke and then this convert files source. Fortunately, we don't have TypeScript help on us out here. but that is on our core, I think. So we can take a device path to a URL and then load it. So that would be like, here we got a file path. And this basically converts it to a URL, in which case we could do a video download. And that's effectively what we're doing here. So we're invoking video URI, which matches up with the command that we've defined and that we have set up in the generate handler. And then after we've invoked it, the invoke is a promise API. After we have invoked that, we will be getting a response of that path. We'll be getting that path back. And we're taking that path, appending it to this video tag. And this is like web browser API. Video download, then starts loading the video. So what's interesting here is we're using a config feature flag. There's protocol asset or not. So I think the README says the example uses a custom URI scheme protocol. There's also the asset protocol. So this might be something that you can make use of in your app. There may be cases where you want to set up your app to do one thing versus another. Now the default, you're already doing some of that in the background using based on the operating system. So if you're on Mac OS, you bundle one chunk of code. If you're on Windows, you bundle a different chunk of code because the Rust crates for Windows are going to have Windows specific functions versus the Mac one. You can also do that directly in your app, and you can do it based off of like operating system, or you could do it with this feature flag. So you can build multiple apps with different features and like bundle them separately. So what we're doing here is, if we're doing the protocol asset, we're going to include this as part of the binary. If we're not doing it, then we're going to stream. Hi, Cameron. Thanks for stopping by. So protocol asset, and I mean, there's not too much here. So what it's doing is it's so that's that chunk. Function is literally returning streaming. So do we have a macro in here or something that is helping us out? Video URI. Okay, so that macro is just the actual command itself. Static string and then a path buff. So we're saying stream, and it's literally giving just this file reference. Otherwise I'm not quite sure the difference between these. So I think we're going to look into them. And basically what it's returning is I think it's returning a tuple of like the protocol that we're expecting to use, and then the like path reference. I'm not sure why this one needs to do a path.push versus this. It's probably something within the implementation itself, but basically with a single command and a feature flag, we can support both of these APIs. this is, I mean, like doing it this way is a little bit more this example or as a demo in Tauri, but you can use feature flags for effectively anything in the Rust side of things. So let's look at, I don't know that we have too much actual like documentation written on this. Let's go ahead and run this other example. I don't know if we're gonna notice a difference. And you can do -- features protocol asset. So that's basically like opting into running the build that will use this other feature. And if you're familiar with like JavaScript bundlers, it's in the same vein of like tree shaking. So I'm going to use this code path, get rid of all the rest of the other code paths. So like functionally, I don't see any real difference. You can see within the app in the web view, like the web view API, like the web APIs have a video tag, and that's got like it shows it's got the built-in like shows you what the buffer, like how far it has buffered. So you can see it here, and you can see that it's sort of like buffering ahead. So every time we get to a point, it grabs the next chunk. So if we kill this and we run the other one, I'm guessing it's pretty much gonna look exactly the same. I think it does that same streaming as well. So if we look at that, the little buffer amount, still buffering ahead just the same. So I think the last bit, unless anybody has any other little rabbit holes or something that we should look into here, I just kind of want to look at the asset protocol versus this what they call it, streaming API. The custom URI scheme protocol. And I don't think we actually have any docs on that. Let us check though. Commands. So using something like this this is an actual like fetch implementation polyfill that's coming from Tauri Apps plugin 8 HTTP, and it's essentially handling the requests via Rust. So this would be an alternative to, and you're actually bundling in Rust HTTP library. This would be an alternative to what they're doing with that curl command. Persisted scope, process. Yeah, I don't see anything. List of references. Config for the asset custom protocol. Oh. I don't think this really has changed much. Protocol and so that would be allow list. So that's more security related. I'm not seeing anything. Allow list, window config. So asset protocol. Asset. So the default is false in V1, enabling or disabling the asset protocol. And you can see like this was work that was done after V1, which is probably part of the reason that I haven't personally dug into it much. Also, I haven't really needed this type of API. Where? Enhancements. All right, let's look at the Rust API. So if we search for asset protocol, asset protocol scope, the application's asset resolver. I was kind of hoping that we would have some examples directly in the Rust side of things. I'm not seeing anything though. What else do we got? We got struct. Okay. We can also go this route. I have in my VS Code, I have an extension called GitLens, I think. I think they've got a paid version as well, GitLens. But you can see it loads basically like on the fly, it does a git blame. So we can see here that actually if we go to the Rust side of things, we can see when those feature flakes were implemented. So meme type, and then here would be, yeah. So I think we're gonna look at this one. This is gonna open up my other browser, isn't it? Yep. So I think this is part of it. There's asset.localhost. So when you were mentioning where do we store this, if you drop like a video file or a PNG or something into your public folder for a web app, you can go to like your website /video file .mp4 and it'll just like browser will stream and load it. I think the asset protocol is basically like I think it's basically like putting it effectively at a subdomain. So the question is there actually like streaming of the file built in when you use the asset protocol? I think so. I think it's just a like different way to store and load it. So like if you use the audio tag, the specific type, we're cluing it into, you know, this URL is going to be at this place. So you can see here like asset : ://. So I think like that's the asset protocol. So if we do the streaming example, we are saying stream this string. Like it's just giving it into. We don't have any actual switches here. URI scheme is stream. I wonder if we use the URI scheme of stream, it does this with the chunking, where we're doing our custom chunking. If it's not, I think it just does the protocol asset. So it like drops it as subdomain, and we're using like more of the built-in, like if you would go to your example.com/video.mp4, your browser is just going to attempt to like figure out what file it is, then effectively chunk and stream it over the wire. But I think what we're doing here with this streaming API is giving us the ability to be more direct in how we're chunking it. So effectively, rather than allowing the web view to figure it out, we can like pre-compute and figure out what's going to be the best for streaming this over the like web view protocols. I think that's the difference. Let's search in. I don't know if it's going to let me search here. Here we can search for VS Code because we got it. Let's search for streaming. I'm wondering if there's going to be any like doc blocks, is what I'm looking for right now. So we have in the changelog, enhance the asset protocol to support streaming of large files. So this part of this work has been because we were running into issues with larger files. So this is enhancing the asset protocol. I think the asset protocol has been around longer, I believe. Migrate to latest custom protocol, allowing partial content streaming and header parsing. Okay. I don't see anything else specifically. I think that's the difference. I think, are you going to allow the web view to handle logic for the streaming, or are you going to do it? I think that, you know, more custom or more like default with, you know, potentially not doing it in a way that's going to be useful for your user or performant for your user. I don't actually see any other docs on that though. Speaking of docs, there is, I do have some interest in doing a stream, like going through the docs and how the docs are set up. If anybody is, and this is sort of just an ongoing general statement of interest for anybody that wants to get into the project on a contribution level. It's always gonna, docs are always gonna be in place where we can use additional eyes and additional effort, either in generating the docs initially, fixing little, you know, inconsistencies or making things clear, and then translating is a thing that we've been slowly working on. We've got a few languages now. All of those are valuable places for somebody to hop in and start contributing, rather than trying to like jump directly into the core Rust, which is potentially more involved. So I would kind of like to do a stream going through that and potentially write some docs on stream, because we still have some places where we've got stubs, and we've done a fair amount with the like window state window customization, where I could probably just write that off the top of my head. And some of these are more just, like, what's a good one? The global shortcut, we looked at that the other day. This is kind of just a base level. Like, how do you install the thing? Literally one example. And like, no comments on the ramifications of doing any of this. Or like, we looked at, I guess we didn't. I was looking at the file system and what was the other thing we're doing? Dialog. This is helpful. And we do have a couple examples here at least. But like the open dialog, there's no, from the docs here, no indication on like, what do you do with this now? So there's always going to be places where you can expand the docs. Anyways, asset protocol. Let's do a quick search. I don't think we have anything about this. We have very little actually in the code as well that mentions it. And even in some of these like PRs and whatnot. Oop, there is still fixes. This is the one I want here. There's really not much as far as description of what's happening here. I mean, this is definitely useful, but like, I don't have any of the existing context. What we can do though is, so this did adjust the streaming example. And we can see here, we are doing strip prefix. Okay. So there's an actual streaming protocol. Got it. Okay, so that's it. The HTTP:// is a protocol. Basically, that's a way to tell the computer what type of interface you want to, make a network request or execute this function over. When you're operating within a web view, we have custom protocols. And especially when you start getting into like, when you get into Android, like if we look at something like deep linking, that has a custom protocol that you can define in your entitlements file. So essentially what ends up happening is when you try to open links, your link ends up looking something like, I thought there's an example here. Open identifier. Setup for app links. Is it in this? I could have sworn they had an example of what the deep link looked like. Okay, there is a link for app links. So on Android, if you set up an app link, this isn't gonna really have the protocol either. Basically, you end up having like, you're setting up a operating system global for a link. So you might see, if you've used Discord before, you might see links that if you have a deep link that you've copied for Discord, it'll be like Discord://. That's a deep link. and effectively a custom protocol. And you're telling the operating system, in this case, right now only Android and iOS is supported for this feature, via this entitlements file, you're telling that operating system that when you have an app link like this, I want you to actually open with the app and not go to like the default browser. So in the same vein of deep links or custom protocols, we have the stream custom protocol, then we have the asset custom protocol. So I'd assume that would be config. I don't know where the custom protocol stuff has gotten into, or where the custom protocol stuff is, because I haven't gotten into it too much. Endpoints? That could be it. Maybe not. Protocol. So asset isolation mod Tauri. So I'm looking for like where it's defined. So this would be Tauri localhost. And that, I think that Tauri localhost is where most of the like events go over. So when you do an invoke or something like that, you're running it over that like custom protocol. And it's kind of in the vein of like a subdomain almost. You're saying like handle this thing in a custom way rather than using the built-in browser. So rather than going to a main page, you'd be going to a subdomain or it's like a separate code path almost. Okay, let's look at the asset protocol. Maybe it has the streaming in here too. Get response, asset protocol paths. Here, this is code that you might recognize. So the asset protocol, we were just using it directly. I think with the streaming protocol, you're opting into basically doing very similar work as the asset protocol, but you get to write it. It's like your own custom implementation. Yep. See, so like multi-part, you know, this was all what we were seeing in that example as well. And here's this random boundary. If we look at the streaming, they have a note here. Boundary ID. Note for production, use rand to create to generate a random boundary. And that's what we're doing with the asset protocol. So I think that's what it is. I think the asset protocol is like a predefined, we'll try to figure out and calculate what makes sense, or like how to best chunk this, which doesn't necessarily, I mean, it's generic. It should work, it might not. So depending on your use case, the stream protocol is you are defining based off of this, you know, here's the protocol and here's the file. So like this ends up being converted into like, I think a stream : / video file name. And essentially you're saying, well, if that happens, I want to, we are registering a custom URI scheme protocol. So if it starts with stream, run this function. If we're doing a asset protocol, that's already defined. That's in core. You use that just directly. So that's expecting this path buff. Yeah, it looks like it. So that's expecting a path buff. And then it figures out the chunks and does all that stuff in the background. Here it is literally defining its own URI scheme, and we're handling that custom URI scheme in a custom way. So you could theoretically define your own custom URI schemes that are just for your app. And that's what it's doing here. And that's why this get stream response code looks very similar to the asset protocol that's existing in the core, because it's effectively implementing the same, potentially with, you know, slight little changes or whatever, just if to show the difference in the example. So if we look at let's look for this real quick. I'm curious if it says anything additional here. Yeah, so this was added in 2.0. Got it. So there's also a register URI scheme protocol, but this one handles async. So this is app files. This is the example here. And it's saying, respond via HTTPS using the standard Rust file system read. Respond to that HTTP request for this custom protocol app files with the data from pulled from the path that the standard FS is grabbing. What else is there? And main. Oh, that's an example that we're looking at. Okay. So there was also the sync version. I'm curious what that example is. Schema protocol. Yeah, so here's an example. So like you could have a custom way to, like, if you have your own custom file type that you, if you try to like load it in the browser is not necessarily going to have an understanding of how to load that. Like you could do Markdown. So somebody opens up a Markdown file, you could have a custom protocol that just generically handles opening up and converting that Markdown file into something that you can render. So then what you could do is you could, on the Rust side of things, handle that Markdown, convert it into HTTP and return a response that displays that Markdown in the transform version that's now like HTML. Okay, yeah, so I wanted to look at the sync one. Register URI scheme protocol. Let's see if that has any examples. And that came in 1.0. So what we're getting in 2.0 is basically the async version. And that's useful for, like the custom streaming example, like making that request and figuring out the chunks. That ends up being more async type work in this, or in the way they have it set up. Yeah, so 1.5. I like this new feature in VS Code. I don't know if y'all have seen this yet, but it will. I don't know what it's called, but it does these like rolling headers. So as you scroll, it, based on the sections that you're in, does those headers, which is really nice. So here's an example. Okay, so this one also uses the app files. And it's available to all web views. So like you could theoretically have, what else could you do with this? I guess this would be a way to like, somebody, if you want to have like a code editor that handles TypeScript, might have a way to load and display the TypeScript. whereas the web view itself is not going to understand that file type, and it's going to, like if you try to just load it, it might just be like a, like a string. It'll expect it to be a bunch of text. So if you want to do anything custom with it, this seems like maybe a good way to do it. Okay. I think I've got a much better handle on it. And I mean, coming back to, who said that before? Yeah, not familiar with today's subject. I think I feel pretty good about the understanding of what's happening here now. We have had the asset protocol, which does the chunking, figures out the chunking, and streams it. You can define your own though. And this example specifically is defining an asynchronous URI scheme, which asynchronous was added in V2. That asynchronous URI scheme in this example is setting up a get stream response, which we have a feature flag to bounce between the two different patterns. So if you're using the streaming protocol feature flag, it will use this custom chunking code. So in the same vein, you can register your own asynchronous or synchronous URI scheme protocols to then, anytime you try to load a file or handle file in the web view, you can have a custom protocol that your app effectively is understanding what's happening with it, which is really cool. I think this is really neat. I knew the custom protocols were a thing. I didn't realize that we had the ability to, in your app code to handle things so custom in this way. And it looks like this was all a V1 thing. I definitely did not realize that we had this sticking around for this long. So y'all are learning with me. There's a lot going on in this code, and I don't have, at the moment, I don't have paid job time that allows me to like really dig into the deep pieces of this. So that's why I like doing it on stream. Y'all can learn with me. I think that's about it that we're going to do today, though. This was an interesting topic because it actually had a bit of a twist. I did not expect to... I didn't really realize what this example was doing until we really dug into it. So this was really good. If not for me, hopefully for you. Or it was for me. I'm hoping it was for you too. Say hi, kitty. Nope, she's shy today. She just wants cuddles. I'm gonna get the tail. All right, that's what we're gonna call it today. Thanks for stopping by, everybody. Again, I already have next week's topic scheduled, so feel free to do all the YouTube things. I think they can there's a button to get notified. So if that's something that interests you, go ahead and do those things. Okay, we don't need cat butts on stream. And again, a bunch of guest streams that I'm hopefully going to get scheduled, and other topics that we will end up doing in between. So speaking of topics, feel free to keep dropping comments below. I appreciate anybody that has already, and that's been really helpful in deciding what makes sense to dig into next. So I appreciate anybody that has taken the time or has ideas that they've brought up. We've been like in between the ideas that I've had or wanted to dig into. We've been doing those as well, which has been really fun. And I think we can kind of keep doing this all the way through to the stable release of V2, whenever that ends up specifically landing. Well, I don't know. We'll go from there. But this has been really great to dig into all the different pieces of Tauri, and I hope you all have appreciated coming along for my learn live. Have a good rest of the have a good rest of your Tuesday, good rest of the week. And we'll see you next week for system traps. Bye, everybody.